Hello TaleForgers! In this video we'll implement the first type of enemy, the moving enemy, which will patrol the platform. When it reaches an edge, it will wait for a moment, so idle, and turn back until it reaches the next edge. So let's dive in! Let's start by creating an enum that has two states, namely idle and move. We'll use this enum to implement logic in the MovingEnemyAISystem. Now open MovingEnemyComponentData and inside it let's create new fields, public double idle time to store the idle duration, idle finish time to set this time inside system and check if idle is finished. Also MovingEnemyState to determine what state the enemy is currently in. And the last one, ground collision filter, to check if our moving enemy is hitting ground. Okay, so create new serialized fields for the new variables. Double idle time and two fields to store the physics category tags. Ground belongs to and ground collides with. Of course, let's prepare getters for the idle time and collision filter, which is created from two other variables. In the bake method, we need to pass additional data to the MovingEnemyComponentData. Before we go any further, let's remove unnecessary debug.logs from the JumpingEnemyAISystem. Same operation for the MovingEnemyAISystem. Great! We need to modify local transform and read properties from the physics collider. So let's add these types to the query builder in the onCreate. Next, let's copy and paste getEntityCommandBuffer from other IceSystem. Also, let's add missing required for update. Let's cache entity command buffer and pass ref state. We want the operation to be correctly queued in the entity command buffer, especially since we will be executing them in the for each. So let's write var MovingEnemyComponentData equals state.entityManager, getComponentData, MovingEnemyComponentData, and pass entity. Then cache local transform also via Entity Manager. Before we move on, let's create 5 new methods. We'll use them in a moment. Firstly, create private unsafe bool is grounded with parameters ref system state, MovingEnemyComponentData, entity, and local transform. Next, prepare private void move, ref system state, enemy manage component data, moving enemy component data, entity, local transform, and entity command buffer. Quite a lot of parameters, but we will need them all to handle our movement correctly. Then let's prepare private set move method with same parameters as the move function. Our forward method, idle, will have exactly the same parameter list. In the case of the set idle method, we have almost the same parameter list, just remove local transform. Okay, let's go back to the onUpdate and check condition. If MovingEnemyComponentData.state is equal to moveState, we want to move enemy to the next position. So let's call move and pass all necessary parameters. Then let's check if our enemy is grounded. If yes, continue. But if not, he will fall into the void of the eternity. Just kidding. We will prevent that with set idle state and call continue, so we will end this iteration early. At the end of the method, let's call idle method, which will wait for the idle time. Okay, it's time to implement isGrounded function. First of all, we need to cache collision word because we want to cast ray to detect ground. Remember to add missing require for update. Next, cache local transform position. After that, we need to store physics collider, so state.entityManager.getComponentData physics collider and pass entity. As you can see, we have unsafe keyword in the method. It will be helpful in the case of the next operation. It as var box collider equals box collider pointer physics collider.collider pointer. From box collider, we can retrieve box geometry, which will be useful to get half extents geometry.size divided by 2. Finally, we are able to calculate x shift, so half extents.x multiply math.sin MovingEnemyComponentData.movement speed. We need to multiply it by the sign so that our detection will change direction when the enemy changes movement side, left or right. Let's create a raycast input with input parameters. Start equals new float 3 position.x plus x shift position.y position.z. And equals to the new float 3 position.x plus x shift position.y minus half extents.y multiplied by 2 position.z. And of course, filter from the MovingEnemyComponentData. I have multiplied half extents by 2 to increase array length. It can be 3 or other value as long as array length is not too short or too long for detection. Let's return collision word.cast raycast input, so it will return bool, true equals hit, or false, which means no hit. Okay, it's time to implement move method. We need to calculate a new position, float 3 position, equals to the local transfer.position, so current enemy position, plus MovingEnemyComponentData.movement speed multiplied by system API.time.delta time multiplied by direction vector. It is simple new float 3 1 0 0. Of course, let's set component data via ECB and assign new position to the manage object. And that's it. Now in the setMove method, we need to set bool move to the true and state to the move state. Remember to set movement speed to the opposite value. Then we need to set component to propagate changes. Last thing to do, let's rotate our enemy by 180 degrees in the ECS and the mono representations. Of course, don't forget to set local transfer component. Idle is a short function. We need to calculate the difference between idle finish time and elapsed time from the system API. If this difference is less than or equals 0, we call setMove method. We need to implement one last method, setIdle, in which we set animator move state to the false, enemy state to the idle, and set idle finish time to the system API.time.elapsed time, plus MovingEnemyComponentData.idle time. Of course, remember to call ECB.setComponent. Let's rename entity command buffer to the ECB. Okay, go back to the Unity editor, wait for the compilation process to finish, it's time to modify enemy prefab. Let's change physics shape size X and Y to 2. Previous values were too small to correct working. Next, let's remove physics body component in the moving enemy. It is unnecessary for the linear, simple movement. Don't forget to adjust parameters, set movement speed to 2 and idle time to 1.5. Then we need to select the correct belongs to and collides with parameters in order enemy and ground. During testing, when I was preparing the material, I noticed that the visualization was reversed 180 degrees. So let's correct it inside MovingEnemy visualization prefab. Okay, so let's go to the level 1 prefab so we can adjust MovingEnemy position, and also let's remove this collectible for now. Great, let's test if everything is working properly. So click play and as you can see, our enemy is moving from one end of the platform to the other. Awesome! I would like to invite you to support us on the Patreon, where you can get the exclusive code, all models, materials or code used in this series, and access to early available content. Link in the description. Thank you for your time. I'm glad you are with us and our community is growing. See you soon in the next video.